Hey guys, welcome to the new video, and in this video we are going to add a new organization, but that organization is running on different Kubernetes cluster, and that new organization will have one peer and it is going to join our application channel, which is my channel, and then we will also install chain code in that new organization and will query and invoke the transactions. So this is the architecture diagram that we are following, and in the past we were having this kind of a setup where we were having one Kubernetes cluster, and inside that we were running two organization and one ordering organization, and these organization were having two peers each, and one of the peer was marked as anchor peer in both the organization. Now the scenario is that we want to add a new organization which is org3, but this organization is running in some different Kubernetes cluster, and this organization will have one peer, and that peer is going to be the anchor peer, and this peer will also be an endorsing peer because we are going to install the chain code in this peer, and we will then use this peer to invoke the transaction and query the ledger. So without any further ado, let's open the DigitalOcean dashboard, and here let me quickly create a new Kubernetes cluster. So I'm going to call it as, let's say, K2. I'm going to give the node pool name as K2, and then here I can give it as K2, cluster name as K2. In this cluster we have to first install the operator, the Hlf operator, and the istio as well, so that we can get the load balancer IP, and then we can do the DNS mapping of this organization with the load balancer. So let's see. Yeah, so cluster is in creation. Let me download the kubeconfig file. So the file is downloaded. Now let me open my terminal here. So I have already split up the terminal in two parts. So this is where our first cluster. So this is the first cluster, and if I do kubectl get pods in the fabric namespace, we should see all of our pods. Like we can see the peer pod as well as the CA pod here. So you can see we have the ordering CA, ordering node, and then the CA and the peer pods. And let me quickly export the kubeconfig. So export kubeconfig, and that is in this location, my downloads folder, and the file name is this one, kubeconfig2. and if I do k get pods, I should get nothing because I think the cluster is still in creation phase, so we have to wait for a while. Yeah, as expected we are getting the error, so we have to wait till the cluster creation process is finished. Let's try again. Yeah, so our Kubernetes cluster is up and running, and now we have to install the istio here so that we can get the load balancer IP, and then we can use that load balancer and map our DNS. So let me install istio here, and we have to also install the Hlf operator in this cluster. So let's wait for the istio to finish up. Yeah, so istio got installed successfully. Let's check if we have the load balancer IP or not. So if I do kubectl get svc, and let's check for the IP. Yeah, so the IP is still in pending. So meanwhile this load balancer is getting created and IP is being provisioned to us. Let's install the Hlf operator. So let me go to the Hlf operator directory, and let me run the command helm install Hlf operator. So this is going to install the Hlf operator into this cluster. Yeah, so it got installed. If I do get pods in the default namespace, I should see the operator pod. Yeah, so we have the operator pod and it is still in creation phase. Let's check if we have the load balancer IP yet. So it is still in pending phase. Meanwhile, let me open the lens ID, and there let's also set up this cluster. So this is the lens ID. This is my another cluster, which is cluster 1, where I have all the organization org1 and org2. And now let me add second cluster, and let me browse for the file. Let's try to create the cluster here. If I go to network and then services, yeah, so we don't have any IP yet. Let's wait for it to get the IP. Yeah, so we got the IP. This is the load balancer IP. Let me just copy this IP and let's go to our DNS settings and let's add the A records for our new organization. So let me refresh this. So let me log in again. Go to my domains. Go to manage domain here. Then manage freenom DNS. So these are the DNS record for the cluster 1, like these are pointing to the cluster 1. So let's add the DNS record for second cluster. So this is the CA that I want to give. Then let me add another for peer, org3 hyphen peer1. This is the IP address, and I don't think so I need any other subdomains here. So let's save changes, and we have to wait for these records to get updated. So let me do ping on my terminal. Let me clear up this and let's do ping for org3 hyphen CA, and then the domain name is hlf hyphen blockchain .tk. So probably it will take 10 to 15 minutes just to get the DNS record update. So we have to wait for that time. So I will pause the video here and we'll resume once the records are updated. Let's try ping again. Yeah, so this time the records are updated now. And now let me go to the same directory from where we were running all of this demo. That was hlf demo. And now we have to create the CA for the org3. So let me first set up the storage class here. We'll make it, and let's export the domain here as well. Now let me create the CA here. So this is the command which is going to create the CA. This is the command which is going to create the CA. Okay, I have to create the namespace as well. First, let's create the namespace. So now let's create the CA. So CA got created successfully. So let's check if the CA got created or not. So if I move to the lens ID, here we can see our CA is up and running. And now we can create the identity for the peer. So here we can see that the user is org3 peer1. Let's hit enter. Yeah, so the identity got issued, and now we can create the peer. So let's create the peer, org3 peer. And here you can see the host is org3 peer1. This is the same record that we created in the DNS as well. So let's hit enter. Let's move to the lens ID and verify this as well. Yeah, so it is in creating phase. Let's register and enroll the peer admin. So this command is going to register and as well as enroll the peer admin. And as a result of this, we should see one file with name org3 peer.yaml. So looks like we have some problem on the enrollment. So let's re-enroll the identity. Yeah, so it got re-enrolled successfully. Now let me clear up this, and now let's get the connection profile for org3. So here we should get the connection profile, and if I do ls and if I do cat of org3 org3.yaml, we can see we have the connection profile here. Let me clear up this, and now let's add the admin user to the connection profile. Yeah, so it got added successfully. And now let's try to fetch the crypto material for org3. So if I just run this command, this should create one directory with name crypto config, and that will have the crypto material for this organization org3. If I do ls, we can see we have one folder crypto config, and if I do ls crypto config, we should have peer organization, and inside this we can see we have org3 MSP, and inside that we have the certificates. So if I do tree of crypto config, we can see we have CS certificate and as well as the TLS certificate. So let me clear this, and now after this we have to create a channel update from the cluster one, so that we can add this org3 definition into the channel, into my channel, so that we can easily join up the channel. So I will just make this bit bigger, and here let me run this command, which is going to give us the organization detail. Basically it will give us the config tx with org3 details. So if I hit enter, so you should see one config tx.yaml file, and this will contain the detail of org3. And if I just open my VS Code head here, we can see, let me make it a bit bigger. Yeah, so we can see that we have this file which is config tx.yaml, and this has the org3 definition. And we can see we have this crypto config as well, which contains the CS certificate as well as the TLS CS certificate. So now after this, we can simply use the config tx later tool to basically convert this org3.json into a protobuf format, so that we can do the channel update. So here to this config tx later tool, we are passing the org3.json. This is the same file which we got as a result of previous command, and then we are converting that file into the protobuf format. So we should have that file here as well. If I do ls-la, we should see that file with protobuf format, this one. Let me clear up this, and now we can create a new modified file which will contain the org3.json. If I just run this command, so basically this is going to add org3.json in the payload, and then it is going to create a JSON, and then we can again use config tx later tool to convert this JSON to protobuf format. So now let's convert this JSON file to the protobuf format. So this is the command config tx later. Input is our JSON file, and the output is the protobuf format. So if I do ls here, we should see this output, which is config update in envelope. So this is the file which is config update in envelope.pb. Now let's sign the transaction using both the organizations. So I will be going to sign the transaction one by one. So let me clear up this. Let me put the command to sign the transaction from the org1. So this is the command sign update, and then we are passing the channel name. Here we are passing up that protobuf format that we just generated. Then we are specifying our network config file. Then we are specifying the MSP ID, and then we are specifying the output. So if I just run this, we can see that it was signed successfully, and let's sign this update using the org2 as well. So this time the command is almost same, just that we are passing the org2 MSP this time. Okay, Okay, we got some error. Yeah, so here it should be awk2. Yeah, so the signing was successful, and now we can submit this channel update. So while submitting up this channel update, we have to pass the signature of both these organization, because currently our network runs in majority of signature policy. So we have to provide the sufficient number of endorsements in order to sign the transaction. So if I just run this command, and here you can see that we are doing the channel update on my channel, and here we are specifying our file, which is the update, and then we are specifying both the organizations. So here you can see we are specifying the org1 MSP, and then we are specifying the signature, and then this for the awk2, and we are specifying the second signature. So if I just specify only one signature, it is going to give us an error. Let's see this. So it will try to sign, but here you can see that it requires majority of 2 admins to sign this transaction. So our policies are not fulfilling. That's why we are getting this error. So now let me run this command, but this time with both the organization, with both the signatures. So let me run this. This time it should run. So here you can see the channel update was successful, and now now we can move to the second terminal, and now we have to update our network config, which is nothing but just the awk3.yaml file, and update the order detail into that, and then we can join the channel. So if I open my VS Code here, let me close this. So here, this is our awk3 network config file. This is the awk3 network config, and here we have to make one change. We have to basically add the order detail. So if I open my network config.yaml here, let me open into this side, and I have to add the order detail only. So first is this one. This I'm going to add here, and after that we should have an order section as well. That section I'm going to add. So let me just copy this, and let me put that order section here. And I don't think so I need any other change here. So everything else looks good. Now we can go to this terminal, and now we can join the channel. Let me put the command to join the channel. Okay, let's try again. Yeah, so here we can see the channel got joined successfully, and now we can add this peer as an anchor peer to the channel. So if you don't know anchor peer is used for cross organization communication, so that all the organization are communicating to each other via this anchor peer. So let me run this command, and this is going to make this peer, which is awk3 peer1, as the anchor peer. Okay, I passed the wrong network config. Here I have to give the awk3.yaml. Yeah, so you can see that the anchor peer got updated, and let's go to the lens ID and see this peer logs as well. So if I go to lens ID, this is the peer, and if I just show you the logs, we should see that it received some data as well. So here you can see that it joined the channel with the 3 organizations. So now we have 3 organizations. The first is awk1 MSP, then second is awk2 MSP, and third is the awk3 MSP. And it started getting up the blocks as well. So you can see that it started getting up the blocks. So you can see it got block 7, block 6, it got block 9. So it got all the blocks as well. So now let's install the chain code in this peer, and then we will do some chain code in invoke and query part. Let me clear up this. Let's install the chain code here. So we are specifying the path, then this is the network config, then language, it's Golang. And then the label is chain code name. So this is fine. Let's try to install the chain code. So looks like the chain code is getting installed. Let's go to the lens ID and see. So here we can see chain code is getting created, and after that we have to just approve the chain code, and then we can invoke the chain code. Yeah, so the chain code got installed successfully, and let me just export the package ID here. So this is the package ID, and now we can approve the chain code. So this is the command which is going to approve the chain code. And here if you remember, so when we install the chain code on the first cluster, so there we were using the sequence number as 1, but if we are installing this chain code in some another peer, like after the general update and all those things, then we have to increment the sequence number. And the organization policy this time is I am including all the 3 orgs here into this endorsement policy. So let's hit enter. So probably I think I have to set up this package ID again, and the name should be Fabcar here, and the sequence number should be 2. Let's run this command. Yeah, so the chain code got approved, and now we can simply invoke the chain code and query the transactions as well. So now let's try to invoke the chain code. So let me put up the command here. So this is the command which is going to create an car into the chain code, and with the function that I'm going to invoke is create car, and these are the parameters. So let me try to run this command. So we got the transaction ID back, which means we were successfully able to invoke the chain code. So this was pretty much it in this video. In this video we saw how we can add a new organization to some different cluster, and then we can join the peer of that organization to an already running Kubernetes cluster with some peer organization. So if we just go to the architecture diagram that we have here, so here we can see that we were successfully able to achieve this. Like we got the load balancer in the cluster 2, and then we successfully create the CA, and then we created the org, and then we create the anchor peer, and then we installed the chain code, approved the chain code, and at the end we tried to invoke the chain code as well, and it was running perfectly fine. So that's all for this video. If you are enjoying these videos, then please like and subscribe to the channel, and I will see you in the next one.